In this lesson, we're going to have a look at how to work out composite areas. Now, there's a couple of things that you need to notice. The first is that figures that cannot have their areas calculated using one formula only, such as a triangle on its own or a square on its own, when they're joined together and you need to use more than one formula, we call it composite areas. So the area of a composite figure can be calculated by dividing it up into shapes, what we call identifiable shapes, shapes that you already know, and then we add them together or subtract if necessary to find the total area. So in this particular example, we have a rectangle and a triangle. So the two shapes, if you can see them there, are a rectangle and a triangle. So we could say in this case that the total area is equal to the area of the triangle, which is a half, times the base times the height, plus the area of the rectangle, which is length times width. So when we put all this together, the base in this case for the triangle would be 14. The height, now the interesting thing about the height is that you've got 8 here and it goes up to 11 altogether. So that would give us 11 take away 8, which is 3. Now we could have the length here at 14 and the width here at 8. And what I'd like you to do with your calculators is to check the answer. It should come out to 133 centimetres squared. Remember, we're talking about area. So check that out and you should be able to get your shape quite clearly there. Let's try another example. This is an L shape, and what we're going to do is to divide the figure, and I'd like you to write this down because these are your study notes. Divide the figure into two rectangles. And then find any unknown side lengths. So find unknown lengths, because we'll need those measurements. So if we have a look at that, that's 15, that's 8, that's 7, that's 8. Everything's there that we need. So we would say then that the area would be the length of, let's say, this rectangle here. So we'll call this area 1, plus this we'll call area 2. Now we know that this is length times width, so that would be 18 times 8. And we know the other area is 7 by 8, 7 times 8. And calculate that, and you should be right. We've got 200 centimetres squared. Check the answer and just make sure that you can get that right as well. Now, when we get a shape like this is one that we did have a go at a while back. Just get rid of those markings. But we'll just do a quick review. This is called an annulus because it's a shape of a ring. You've got a shaded area, which is what you want. So to find this, we could say that the shaded area is found by calculating the total area and then subtracting the unshaded area. The total area, that's the total area of the whole circle, the outside circle, then subtracting the unshaded area. That's the small circle inside. So writing it out in a better way, we could say that the area is the area of the large circle minus the area of the small circle. So let's see, we know it's pi r squared, pi times, now we need the radius of the big circle. Now we know from here to here it's 5, that's the small one, and then the little band here is worth 2 all around, so that would have to be a total radius of 7 for the big circle. And we subtract again pi r squared, this time you've got a radius of 5, so that would be pi times 5 squared, and if I wrote this out long ways, that would be 49 pi minus 25 pi. It's good to write it like this before you simplify it, because then you have far less in the way of rounding errors. Now 49 pi take 25 pi, think about like terms, and you'd end up with 24 pi, and that's centimetres squared. Now that's the exact size of it, but of course we're not going to write it in this case with pi in it, so we're going to use our calculator and we're going to round to 1 decimal or 2 decimal places, let's say. So we'd get, if you just check your calculators, 24 times pi should be 75.40 centimetres squared to 2 decimal places. That should work for you. So there's an example of how you subtract some areas to get your final shape. And we'll just do, I think, just one more example. Here's a situation where you've got a circle that has the same area as a square with sides of 10 centimetres. Find its radius. Right, so let's actually have a go at drawing the square first of all. So let me see if I can find, here we go, there's a square. There's my square. Now what I'm going to do is I'm just going to put a little dot on the page here, and I'm going to now draw a circle with a radius. So I'll start here and expand that out. So maybe make it like that. And then what I'm needing to do is to find that distance there as the radius. That's what I'm trying to find. Alright, so let's see what we can do. What do we know? First of all, we've got a square and a circle with the same area. And we know that the square has sides of 10. So they're 10 centimetres each. So let's work out the area of the square first of all. We could say that the area of the square is equal to 10 times 10, 10 squared, which is 100 centimetres squared. So that's the area of our square. Now that's also the area of our circle. But we know that the area of the circle is equal to pi r squared centimetres, but we don't know what the radius is. But we do know that this and this are the same. The area of the circle must be 100. So let's make up an equation. Pi r squared must be equal to 100. Now, doing a little bit of algebra, we know that r squared, to get rid of that pi, remember we divide both sides by pi, so we must get 100 divided by pi on that side. So that is approximately equal to, if we work it out, to 2 decimal places, 31.83. You can check that out with your calculator, which you should do. I'm just going to move this up a little bit. 31.83. So that's what r squared is equal to. I'll rewrite it here. Approximately equal to 31.83. Okay, now at this stage we can find r, remember, by taking the square root of both sides, because the square root cancels the square. So if I take the square root of 31.83, I will have my answer. Now, you know that when you take a square root of a number, it can be positive or negative. You think about it. The square root of 16 is 4, because 4 times 4 is 16, but so is minus 4. Minus 4 times minus 4 is 16 as well. So you can always get a positive and a negative answer when you take a square root. However, because we want a distance, we're not going to have a negative answer. So our answer in this case, if we use our calculator and round again, this time we're going to round to, say, 3 decimal places, it should be approximately 5.642 centimetres in length. I just might write that little bit there again better, because it's just come up unusually. So let's try that again. But that's your distance. Check it with your calculator, 5.642 centimetres. And there's a way of using a little bit of logic to work out a missing value. You're going to have to practice these and get them right, but with a little bit of practice you will be able to master them.